All right, so welcome to the first lecture of data structures for June 2020. Um, first things first, um, let's go ahead and kind of talk about what we're going to be doing in this class. As you have hopefully read on FSO already, we're making some pretty big changes to the course, and this is um, kind of the month where I'm just going to go ahead and uh, finish all of the new labs. I don't have everything finished yet, which is why you can only see the week 1 labs currently on FSO. I have most of the other ones done, but there are a few that I need to write and tweak for each week. So you're only going to be able to see a week at a time. Um, Normally, that wouldn't really matter for campus students, right? But for online students, um, they need to have all of their week for the week work for the week available on Monday, right? So because I have no idea when they're actually able to get work done throughout the week, right? So I want to have everything available to them. Um, so so we'll only have two to three labs a week. The first week and the third week we'll have 3 labs, and the second and fourth week will just actually the second week has 2 labs and the third week has just 1 lab. So actually before we can go ahead and do it here. Um, so I'd like to kind of talk about the breakdown of things, and also kind of talk over kind of the rubric for the class. So I'm going to go ahead and pull up FSO here and drag that over, and talk about a couple of things um, that are important to know. Let's pull up, where are we at here? Data structures. Let's do a preview here. All right. Okay, so important things, right? Obviously, everything on here um, is important, right? You should uh, look through everything in the course. Um, so I posted up, right, the info for all of the lectures, right? When they're going to be, right? When the labs are going to be. Um, Labs are going to be at 5 p.m. Um, the lab instructor, who is normally Phil Bruyere, will post up the link to the Zoom up on FSO around, or I'm sorry, not on FSO, on Discord around 5 p.m., kind of like I did with this lecture. Um, he'll post up the Zoom link. I would recommend highly going to that if you're able to. Um, Not only if you just have questions, but also to give yourself a structured time to just work on the lab, right? So, just utilize that time just like you would in a campus lab, right? Like if we were on campus right now because we're not dealing with this whole COVID thing, right? Then you would be in lab working on your lab. Even if you didn't have questions, you would work on your lab. And then normally on campus, when you finish the lab, we would like check you off and you would be able to leave early. So we can still maintain that in the virtual environment, right? But there have been numerous instances over these last few months when people were working virtually, um, where people were scrambling at the last minute to get their labs done, um, because they weren't using good time management. And I completely understand that this environment that we're in right now is not something that a lot of us are accustomed to working at home, right? And so there's a lot of distractions at home that we don't see on campus. So um, we can try our best to kind of give ourselves a structured environment to, like I said, say, hey, between 5 and 9 on Monday, Wednesday, Friday, when I have a lab, I'm going to go ahead and work on that lab, and more than likely you'll probably get it done within those 4 hours, and then you don't have to stress about working on it the following day, right at the last minute. Um, Typically labs are going to be due before the next lecture. So like tonight's lab is going to be due tomorrow night at midnight, right? So you'll basically have 2 days to work on that for campus students, right? For online students, things are set up a little bit differently, right? Online students are going to hear this lecture as well, so I don't want to leave them out. So just, you know, try your best to allot yourself enough time to work on the project, right? Um, we're going to be available a lot, right, to help you. Even I'm not going to have any structured set aside office hours over the course of the month. I'll just be monitoring Discord pretty much all the time when I'm not sleeping. I'm usually at the computer, or, you know, occasionally, you know, doing some exercise or something like that. So I should be able to get with you, and we can do one-on-one office hours via Zoom. We can talk on Discord, you know. So we're not going to set aside any specific time, but I will always be there to help any of you that have questions about anything that we can help you out with. All right. Um, so like I said, we're going to have a number of labs. Basically, every lab is independent of each other, right? Um, so, but it's mostly going to be done in one solution, and this is very different than the way that we have done it in previous months. Since I took this course over in January, I've been working on getting some new material in there and redoing pretty much all of the labs. So we're going to see all new labs this month. All of the old material is going to be gone from the lab side of things. We'll look at some of the PowerPoints and slides and stuff that are still old that I haven't updated yet, but they still kind of work. So last month we saw some of the new labs get introduced, and we're going to go ahead and roll out the rest of them for this month. So we've got the list of lectures here, right, as well as the topics. So today we're actually not going to really talk about any data structures specific things. We're just going to focus on debugging, and we'll get more into that once I finish up this introduction here. And then essentially not every other day, but vector, list, and unordered map are classes that are built into the language and what we call the STL, or standard template library. I know you guys have already used vector before in systems programming. You guys have used list in C#, right, or linked list. So we're going to be looking at that. And this guy here is kind of similar to the dictionary class that you have in C#, right? So we're going to look at kind of some of the built-in stuff, because that's ultimately what you'll end up using out in the industry. For most purposes, a built-in data structure is going to work fine. There may be instances where it doesn't do exactly what you want it to do, and then you have to build your own version of that data structure, or somehow tweak or extend that structure to do what you need it to do. And so basically what we're going to do is we're going to use the built-in version, and then we're going to write our own version. So um, the reason why we're going to write our own is to kind of understand the pros and cons of a particular data structure. So like a vector and a list can do a lot of the same things, but one is going to be more beneficial to you in certain circumstances. So building our own versions of those data structures and understanding what's happening underneath the hood, so to speak, will um, will allow us to make a more informed decision when we enter some problem and that we need to solve when we say, hey, which data structure is going to be best to tackle this, right? Um, so so like I said, those three, the lowercase ones, vector, list, and unordered map, those are built into the language. On those lecture days, we'll spend a good chunk of time in Visual Studio, kind of um, looking at some of the functionality for those structures. And then on Dynarray, DList, Dictionary, we're basically writing our own versions of those classes. And then the last two labs, binary search tree, there's not a tree class built into the language. So we're going to end up writing our own. There are a lot of applications that use trees. So it's very important that we understand how trees work. And then the very last lab is a very cool lab where we're going to look at basically doing more or less a zip compression. It's called the Huffman algorithm. So we're going to talk about that, and that's going to end up utilizing tree data structure in order to do that, as well as some other data structures that we'll get into. All right. So that's that. Let's go back. Lab policies, right? So as you've seen here, right? Make sure you read this. Make sure you complete, because this is a weighted assignment, right? So we're only going to accept labs up to 3 days after the due date, right? With each late day being 10% off, right? So make sure that you're getting your labs done on time. Going back to what I mentioned earlier, right? Working during that lab time during 5 to 9 on Monday, Wednesday, Friday will help to ensure that you get that lab done on time, right? What I don't want, right, and what's happened in the past is before I rolled this out, I didn't have a late lab policy, and people were submitting everything at the end of the month, right? So I don't want people to cram for and do everything over the last weekend, right? Because that's very stressful. It's also very stressful for me to have to grade everything at the last minute. So, you know, this is pretty standard, right? That we want to keep you guys on top of things. In some other classes, labs build on each other, right? So you have to keep on top of things in order to keep the ball rolling, right? As I mentioned, we do have a single lab project for the course. This doesn't currently have all of the labs in it, right? It has most of them, right? But there are, like I said, there are a couple of labs that I still need to write. So this will need to be updated. So every week, every Monday, you'll probably have to go back to this project, or I'll send out an announcement or something for you to grab the new version of this project that has the new labs in it, right? And at that point, you know, if you want to copy over your old lab files that you've written into the new project, just so you have like one unified everything in one place, then you can do that, right? Professionalism, right? Every class has professionalism. Attendance, like I don't know what to do with attendance right now because we're not on campus, and you know, I'm taking attendance in here, right? So I see the couple people that are in here. I would like to see more, right? I posted up that I'm giving bonus points for people that show up to the lectures for campus students online. We'll figure some kind of participation way that you can get some bonus points as well, right? Because I don't want to isolate you guys from anything. So we'll figure something out for the online students that aren't able to make the lectures via timing constraints and whatnot. Also, Discord, right? Make sure that you're active on Discord. Asking questions. Also, just showing up for the labs. I can count that towards this Discord grade as well. So if I ask Phil if a certain student has been in the labs and he says yes, then I can go ahead and mark you credit for this Discord activity, right? So either be active on Discord, asking questions, answering other student questions, or participating in the labs, and we'll say that that's good to go. And then we have the week 1 labs so far, right? So let's go ahead and talk about this debugging lab real quick. This is what we're going to focus on during the actual like material portion of this lecture. This is going to be a little bit different than the rest of the labs. So I know you guys have had a debugging lab in systems programming. I don't know exactly how that's handled, but this is how I'm choosing to handle things for now, right? And this worked out okay last month. So debugging is a very, very, very important skill as a programmer, right? It's very unlikely that a person, even a programmer that's been writing code for 20 or 30 years, to be able to write a program and of any substantial size, right? Not just discounting anything that's super simple for a seasoned programmer, right? But any programmer, including myself, right? I'm not going to write it perfect the first time, right? I'm going to make a typo. I'm going to call a function wrong. I'm going to do something, right? And I'm going to crash, or I'm going to have a memory leak, or a compiler error, or a linker error, or any number of things. That's going to happen. Now, it's very important for me to know how to correct that, right? So I know many of you guys rather have only been, maybe programming for a short time, right? Like you came to Full Sail and that's the first time that you started to program. It's important to learn early how to use the tools that are available to you. So this lab, like I said, is going to be a little bit different. Essentially what we're going to give you is a broken project, right? This project is going to have a number of errors in it, and you are going to have to fix it. Now, unfortunately, right, because of that, we can't tell you exactly how to fix the problems. So we're going to go over in Visual Studio a project that's fairly similar to this one, that has a lot of the same problems, not 100% the same problems, but a lot of the same problems. And we're going to fix that broken project. And we're going to look at all of the tools and ways to fix those errors, right? So this lab, unfortunately, the way that I have it set up, you're not going to be able to get help on the specific details of any specific error that you're having. So, we're not going to be able to tell you how to fix something in this project. We can tell you how to track down how you would fix it, right? So we can show you how to look up an error, talk to you about what an error means, show you how to detect a memory leak, etc. Right? So that's very different than the rest of the labs where we don't have any of those restrictions at all. All right. Um, for the so for these two labs, right? We have no real material here. Let's jump back over to the lab project. Is this new lab information here, right? So we'll take a look at this lab project later on Wednesday when we actually start to work with it. But basically what you're going to be doing is writing a series of functions, and then through a series of pound defines like we see here, you'll be able to test those functions by running it through some code that I've written, and it will let you know if your function is doing what it's supposed to be doing. So this is a very good way for us to see, for you and me to see if immediately if your function is working or not, right? If your class is doing what it needs to do. So again, we'll look more into the details of this project here on Wednesday when we actually encounter it. All right. So that's pretty much what FSO looks like. That's pretty much the way that the class is broken down. Obviously, over the next couple of weeks, we'll have the week 2, 3, and 4 material. So for if you look at these dates here, you'll see that next week we're only going to have 2 lectures. That's because on Friday we're going to do the midterm, which is just going to be a test on FSO. On that Wednesday, so on the 10th, we'll go over kind of the topics that are going to be on that midterm so that you'll have some study material. And then on the last week, we just have 1 lecture. And then you'll have the final will be on the last Wednesday of the month. So we do the 24th, right? So we've got 11 days of this course typically on campus. So it's 3 days the first week, 3 days the second week, because normally we do the midterm, or I'm sorry, yeah, the midterm, 3 days the third week, and then we just have 2 days on the last week. All right. So I think that's it for FSO. Do you guys have any questions on anything that we've gone over as far as like the way the course is laid out? Everything's good? All right. So let's drag that over there. All right. So so here we have Visual Studio, right? This is going to be, your home for the foreseeable future, right? Depending, right? You may not be in Visual Studio when you're out in the industry, right? It depends on kind of where you're at, right? If you're in game development, probably in Visual Studio, right? Although it's not the only C++ compiler out there, but it is one of the best. It's what most people like to use for C++. But obviously, if you're in software, you could be working in any number of languages, right? So you might be in a different environment. But we're doing everything in Visual Studio for this course, right? For game development, you're probably going to be in Visual Studio almost the whole time. I believe, if I'm not mistaken, the midterm project will have you working in Unity, but you'll still be writing code in Visual Studio. but you'll be using Unity as your engine. If you're in software dev, you're going to be working in a number of different environments as you work through all of the various classes. All right. So let's first talk about just what we need to do here. Okay, so we have a project. I'll go ahead and walk through this project real quick and talk about what we're doing. So we have a student class. All right. We have some data members here. All right. So we have data members. So we're going to have a dynamic array for our name. We have just a fixed sized array of 10 grades for our grades, right? And then we have another variable here for the number of grades. So the idea on this is that we have this fixed sized array of 10, but we might not be actually using 10 grades. For reasons, I didn't want to make this a dynamic array. So that's what we're gonna be working with, right? You can see that I've got a capital M in front of all of my data members. That's just what we call a naming convention. So it's just a way that I choose to code, and a lot of people use this same convention to keep things kind of organized and let us be able to read our code easier. So anytime I have an M in front of a variable name, that means that it's a data member, right? So when I'm inside of a function, I can immediately know like where that data is located and who it belongs to. Likewise, for any parameter that I pass into a function, I use a leading underscore. So that again lets me know when I'm inside my function where my data is coming from, right? So naming conventions are very widely used, right? When you're working at a company, there is going to be some form of a naming convention, right? And that is so that when you're reading code that's been worked on by a dozen people, you can read it easily, right? And you're not going back and forth between 10 different ways that 10 different people write code, right? So when you're at a company, you're going to have some type of standard, and everyone there is going to write their code for that project in that way. That way, everything looks as if it was written by the same person, and therefore it's easy to look at it and understand, because that's the way that you're coding in that project. All right. So we already went over our data members, right? We have constructor, right? Destructor, of course, copy constructor, and assignment operator. So these guys make up the rule of three, right? That we went over with John in systems programming. How comfortable are you guys with the rule of three? This is a very important thing to know. So if we need to go over the rule of three again, we can definitely do that. Not very comfortable? All right, so we will definitely go in depth about the rule of three here. Actually, we can go ahead and step over to the whiteboard and go over that real quick. What am I going to do here? Okay. Okay, so what the rule of three is it's the destructor, right? So the destructor, the copy constructor, which I usually abbreviate to CTOR, and the assignment operator. I'll just write op. So we need these three functions if our class has dynamic memory in it. Okay, so let's say that a class, let's write a class just called, let's just call it int with a capital. Okay, and it has a data member that's just an int. All right, and it has some functions, whatever, doesn't matter. Okay, so if you have a class, right, and let's say this is all I have in that class, that's it, right? Or maybe let's say I have, sure, let's just say that that's all I have in the class, right? And so by default, a class gives us a default constructor. So it gives us a default constructor. It gives us a destructor. It gives us a copy constructor. It gives us an assignment operator. And it gives us an address operator, which doesn't really matter. Okay, so if I don't write anything in my class, I get all of this stuff. Okay, now let's specifically talk about these two guys. All right, let's talk about what does the copy constructor and the assignment operator do, right? And then we'll hit up the destructor as well. So let's look at a built-in copy constructor. All right, so our copy constructor here, right, for our int class, we got that scoped in. It's always going to take in a constant reference to whatever class you're working with, right? I'm not going to use my naming conventions here just because it's just more work. So if I am an int class, then I'm going to take in a constant int reference, all right? And if we could look at the built-in version, what it does is it sets whatever data members we have equal to the same data member in the other object, right? So if we said, right, int x, let's just pretend for a second that we have a constructor that sets that value, right? And I say, well, let's create int y and set it equal to x. All right. So this right here, that is a copy constructor call because we're initializing a new object here to another object of that same type. So that is going to call this function here. All right. So now y, right, y dot in, right, is 5, right? Because x's in was 5, and this right here is what the built-in constructor does. or the built-in copy constructor rather. Okay? So, and the assignment operator more or less does the same thing, right? We call this, when we have something like this, we call this a member by member copy. Or you might have heard it called a shallow copy as well. All right. So if you have just objects, just regular variables, right? We're not dealing with any pointers or anything dynamic, then this built-in version is okay, right? Because we can assign an int to an int. We can assign a float to a float, right? We can assign an object to another object, right? But if we have dynamic memory, so let's go ahead and let's create another class over here, right? So let's say that we have a class, let's say we have a class called array, right? And it has an int pointer vals and an int num vals. All right, and let's just say for the sake of argument that we have a constructor that can fill this out, right? So so let's say that we have something like array, or actually we'll go ahead and give ourselves an array. So let's say we have an int nums array of 5 values that's equal to 1, 2, 3, 4, 5. And then I say, hey, let's create an array called x, and it takes in nums and 5, right? So we'll just say we have that constructor, and let's just say for the sake of argument that it dynamically allocates that array for us, right? You guys are comfortable with dynamically allocating an array? Yes, no, maybe? Okay, Matthew says yes. Matthew's going to speak for the class. It's typically how I do things on campus. If one person says they get it, then that's it. If you don't understand, you need to speak up and say, hey, I don't get it, right? So, so now let's create another. Let's see what happens if we use that built-in copy constructor for this class, right? That has dynamic memory in it, right? This is something that we called new on. Okay, so now we go back and look at kind of what this copy constructor would do, right? Is it's just going to assign both of our data members to the value, right? So if we look at the built-in version here, which takes in, again, a constant reference to your class, right? So a constant array reference, and we'll call it ARR, right? Then it says this arrow vals equals ARR dot vals, and this arrow num vals equals ARR dot num vals. Okay, so let's think about what's happening in memory here, and let's go back to this integer one real quick. So let's imagine here's x, right? So here's the x object, right? Let's blow him up a little bit. Let's make them a little bit bigger so I can actually write something in here. So here's X, right? So X, inside of X, we have a data member called N, right? And there's 4 bytes stored within that object, right? So it has a 5, right, stored in that integer. That integer is inside of X, right? It's one of the data members. So now if we have Y, Y has its 4 bytes, again, inside of its object, right? So we just take the value stored here, right, and copy it into the value there. And that's no problem, right? But if we do that over here, right, so here's X. X has vowels, and it has num-vowels, which I'll just write as NV just because it's so. So NV, again, is just an integer, so that's fine. That value is stored within the class, right? But this vowels, that's a pointer, right? So all we're storing there is a memory address, right? So I can't really, I don't have room to write it all in here, so we'll do something like this, right? So we'll come up there and say, right, that I'm storing some memory address, right? 0A264B00, right? So I'm storing that memory address. And so over in my RAM, right, in my heap, I have at that address, right? So at 0x0A264B00, at that address, right? So at that address, there exists this array that's storing these values, right? So I'm just, all I'm doing within X is I'm storing the address of where that array is, right? Whenever I call new, I am allocating memory out in my heap, and I'm storing the address of where that memory is, right? So if we use the built-in copy constructor or the built-in assignment operator, because again, they both kind of do the same thing, they're just called contextually a little bit differently, then we're going to have Y here, right? So Y has vowels and num-vowels, right? So all I've done here, right, is I've just said copy this memory address into this other pointer, right? So that means that X is pointing to this array, right? So we can say, hey, I'm pointing to this array, and then Y is pointing to the same array, right? So that means that if X changes one of the values, right? So let's pretend that we have some functionality where I can change the value of an element, right? I change this to 10 or something. Now y has been changed too, right? Because it's pointing to that same address. What if X comes along and says, hey, I need to go away, right? So when I go away, that means my destructor gets called. My destructor says, I need to clean up all dynamic memory that I've created, right? Every class is supposed to kind of be self-contained and clean up after itself, right? So X comes along and says, hey, I'm going to call my destructor now because I've gone out of scope. So I'm going to delete this memory, right? So this is gone now. But Y doesn't see any of that. So Y is still pointing to that array, and that array is gone now. So now if I try to access the vals of Y, I'm going to crash because I'm trying to access memory that doesn't belong to me anymore. Okay? So that is why when we have dynamic memory in our class, we have to write the copy constructor, assignment operator, and destructor, the rule of three, right? 3 functions. Because the shallow copy is not good enough, right? So let's go ahead. I think I have room here. Let's see if I can squeeze this in here, right? So what we can do, right, is we can say, okay, well, this num vals equals array dot num vals, right? So that's a shallow copy, right? That's just a copying the value of an integer into another integer, right? And that's fine. We're allowed to do that. We're not, that portion of things, we're not dealing with any dynamic memory. We have to manually do that though, right? We have to write this code because as soon as I write my own copy constructor, the default one goes away, right? So that means that I have to fully implement and fully copy everything that needs to be copied, right? So I'll go ahead and assign that int over. Again, that's fine, right? Because this int, it's inside the class, and it's inside the class over here, right? We're not pointing that int to anything outside of the class, right? Out in the heap. Now we need to deep copy or dynamic copy the array, right? So we need to say, hey, this array, or vals rather, this vals equals a new int of size num vals, right? So what that's going to do, right, if I can, let's pretend we didn't delete this. So let's bring this array back. 0, 1, 2, 3, 4. I'm not pointing to that yet, right? So now what I've done is I've said Y has a vals, right, of some other address, right? Maybe this is like 0, 0, 4, 6, 2, 8, BD or something like that, right? So at 0x 0, 0, 4, 6, 2, 8, BD, I have another array of 5 integers, right? And now we need to copy over the data, right? All I've done is I've allocated an array to be the same size, so I have the space, right? So now I need to copy over the data, so we can use a for loop to do that, right? I equals 0, I less than num vals, increment I, right? And then we can say, hey, set my vowels sub I equal to ARR dot vowels sub I, right? So that's going to run through a pretty standard for loop, right? And it's going to copy over the values, right? Or I guess they should be 1, 2, 3, 4, 5, but we can fix that over here, right? 0, 1, 2, 3, 4. So now these two objects, while containing the same information, are completely separate from each other, right? So if X somehow wants to change this value here, right? So it wants to change this value to 42, then that's not going to change Y, right? And if Y goes away and this gets cleaned up via the destructor, then X is fine. Nothing changes, right? Because they're at different locations in memory. All right. Did that clear some things up for you guys? Or did you have any further questions about kind of why we need the rule of 3? All right, cool. Okay, so let's jump back over to Visual Studio here, and we'll continue going back through the student class. So as I said, we have dynamic memory, right? So we have the rule of 3, right? So the assignment operator and the copy constructor are to make copies of the object, right? Or to assign, right? So copy constructors are used when initializing, which is what we just kind of talked about. And this would be an assignment, which means, right, that both objects already exist. And then we've got the destructor to clean up that dynamic memory that's been allocated, right? Which in our case is going to be the name here. Okay. We also have a set grades method, right? So we're going to take in an array of grades that should be in the range values 0 through 100. And then we're going to also, right, anytime we pass in an array to a function, right, we can't know how many elements are in that array, right? Because once we pass an array, it's then just a pointer, right? Every array is a pointer, right? Hopefully John goes over that in systems programming, right? Every array is a pointer. Yes, Zach, you asked a question over in the chat here, right? You said, so a deep copy is copying an array to a new array that takes up a different space in memory. Yes, that is one aspect of it, right? It doesn't necessarily, it's not always going to be an array that's being copied, right? It could be one object that's dynamic within the class, or it could be as we get into some of the data structures, like you guys have seen linked list in PG2, right? That's a node-based structure, so that's got a number of nodes that are going to end up be dynamically allocated, right? We're going to talk in great detail about that in week 2. So yeah, so it's basically a deep copy is when we're dynamically allocating some memory and copying it into another location in memory, right? So anytime we call new within a class for one of our data members, that means that we're going to need to write the rule of 3, right? Because we're going to need to clean up the memory at the end of the function, and then we need to take care of any deep copies inside of that copy constructor and inside of the assignment operator. All right. Okay, so and then we have a display function, right? Just to print them out to the screen. This function is going to be protected with the const keyword, right? So that means that within this function, the student and everything within the student is const, right? It cannot be changed. So I can only look at the student information when I'm inside that display method. All right. So moving over to the CPP, right? We just have the definitions for those functions. We'll go over some of that stuff as we're cleaning up our errors. And then main just has a very basic little application here to kind of test some things. This value is wrong because I added some new variables today. So let me pull up my calc here and see what this is supposed to be. So 40, 60, 100, 80, 35, 10, 90, 55, 75, divide that by 10. So that should be 54.5, right? So we're capping within the set grades method. We're going to need to cap grades because they're only supposed to be 0 through 100, right? So like this grade here and this grade here, we're just going to cap them, which means we're just going to set them to the minimum or maximum bound, right? Sometimes we might call this range checking or range, not range capping, or like setting a floor, right? A upper or lower floor, which means that that's like the minimum and maximum of values that something can have. And we're going to make sure that everything is in between those, right? So this value here, right? Once we get into the function, we're going to set that to 100, right? And likewise, we'll set this to 0, right? Because you can't get if any teacher gives you a negative grade, then they're kind of a jerk, right? Maybe extra credit is cool for some teachers, right? FSO doesn't allow for extra credit, so if we do extra credit for things, we'll have to finagle that and somehow make that work. All right, so we're going to create a couple of students, right? We're going to pass in names to them, right? Just use some cheesy pop culture stuff there. We're going to give them some grades, right? So we're going to call set grades and fill out that information for the student, right? And then we're just going to display them. And then in a quick and easy way to check and see if the rule of 3 is working is we're going to do a swap, right? I don't know if you guys have seen the swap function from PG, or I'm sorry, from systems programming, right? But it essentially does this. Like I know you guys have written a swap over in like PG1 or PG2, right? But it basically does this inside, right? But this is just it's a templated function that you can call, so you don't have to do a swap yourself, right? But this is right here, that's a copy constructor call, right? I'm creating a new student and I'm initializing it to another student. So that right there, that's going to call our copy constructor. And that's going to call our assignment operator, right? And this is going to call our assignment operator too. And then at the end of the swap function, this temp student is going to go out of scope, right? Which means that it's no longer needed within the application, right? The function is over. So that's going to call the destructor for temp. So whenever we do a swap, that's going to test basically all three of the rule of three. All right. And then we're going to display them again after the swap. So they should show up in the opposite order, right? So when I print it out first, it should say Frodo and then Marty McFly with their corresponding grades, however we print those out in that display method. And then I should see them in the opposite order, right? So we should see Marty McFly first and then Frodo Baggins. Okay, so let's go ahead and try to get this program working. Like I said, it has a number of errors in it because I purposely screwed it up so that we could have this project to have some fun with. When you're writing your code, like I said, you're gonna make mistakes, right? It's inevitable. It happens to all of us. So just don't be deterred, right? And try to tackle things as you encounter them, right? So don't when you get to the more conventional labs, like starting on Wednesday, excuse me, let me get a drink of water here. When you get to those more conventional labs, like, don't try to write the entire class or all of the functions and then compile it, right? Take things one function at a time, right? The way that the labs are written, they're very modular, so you can write one function at a time, right? In fact, you don't even have to do anything in any specific order for the most part. There may be some small things, like you might have to have the constructor done first, but other than that, like, you can write any function you want or tackle any function you want. You don't have to just like go through linearly through the tests or through the class, right? You could jump around, and everything should be modular, in that you can, like I said, you can write one function and you can test that one function and see if it works. So I've spent a lot of time working on that and refining it, and it seems to be a pretty good, stable system so far. But I've only done it for a couple of months, so there may still be some kinks. So you guys will have to help me track things down if we have problems, and we'll fix them. But it should be good. All right, so we have this application written already, and let's see what happens. So I'm just gonna save everything because I changed those comments, right? So we're gonna build, right? And we're gonna see that we have two problems that are stopping us from running the application, right? We have a warning and we have an error, okay? So first thing I'm gonna do is I'm gonna show you something, all right? So I'm gonna build it again, right? I'm gonna use the keyboard shortcut, which is Control-Shift-B. I'm gonna build that, right? Oh, it still gave me the warning, okay? Sometimes, most of the time, actually, is this just a warning? Is it a warning? Let's see what it says. Give me just a second here. So a lot of times a warning will go away after you build a second time. It's not, this might be a really bad warning. I'll see at some point in this. Let's see if we can get another warning that will go away. Then we'll talk about how we can clean those up. So first thing I have here is this warning. It says recursive on all control paths, function will cause runtime stack overflow. Okay, so what does that mean? Right? Well, we know some of these words, right? So can someone want to take a stab and explain what this error means? What's that telling us? You can write it on in chat, or you can turn on your mics. It doesn't matter to me. Okay, well let's break it down. So can someone tell me what recursion is, or recursive, right? What does recursive mean? Okay, yeah. So recur, right, means to repeat, right? And for us as programmers, recursion means when a function calls itself. All right. So it's telling me that this function here is recursive, right? And it calls itself. It says it calls it on all control paths. Control path is basically a path through the function, right? So let's say that I have some function here, like let's say right. So if I want to check to see if a number is even, right, we could just mod it by 2, right? If mod by 2 is equal to 0, right, we have no remainder. This is a control path, right? If I pass in a value to the function and it does this, that's one path through the function, right? Or I check the if and I do the return false because I passed in an odd number, then that's another path. That's a control path, right? So so it's telling me that my function is recursive on all paths, right? Which is not good, right? Because that means that whenever I call that function, it's just going to call itself, maybe go down a different path, but it doesn't matter because it's going to end up calling itself again, right? And so the function has no way to exit, right? A recursive function needs to have what we call an exit condition so that at some point that recursion will stop, right? So that says that the function is going to cause a stack overflow. So Stack Overflow is, well, it's a very popular website that you're going to have a lot of experience looking at over the course of your careers. But it's also a mechanism within a lot of programming languages. They use the call stack to keep track of where you're at in your application, right? So for instance, if we look at this, right? So we can say, all right, so let's like pretend I have a call stack here, right? So our call stack starts out and it says, hey, main is called, right? And then main calls the student constructor, right? It calls the student constructor here. And maybe inside that student constructor, it calls new, right? So new gets called. And then once new finishes, that gets removed from the call stack. And then we call another function, like we call strcopy, right? So we can copy the name into our new dynamic memory that we've allocated. And then strcopy is popped off of the call stack. And then maybe the student constructor is done. So that gets popped off the call stack. And we come back to main. And we call the student constructor again, right? For Marty McFly. And that calls new. And then new completes. And then it calls strcopy. And then strcopy completes. And then the constructor completes. And then we come back to main. We run through this stuff, right? And then we call set grades, right? So over the course of any C++ application, as you're calling functions, the call stack is going to grow and shrink, right? As you call functions. Well, right now, it's telling me that my constructor, one of my constructors, I don't know which one right now because it doesn't. It just says that it's the student constructor, is recursive. So that means, right, that it's just going to call itself over and over and over and over and over and over and over until eventually the call stack is going to run out of space. So the call stack has a finite size of 2 megabytes, right? And we can potentially change that through using some tools, right? But by default, a C++ application has a call stack of 2 megabytes and or a stack size, right? So as I continue to call this student constructor over and over and over and over and over and over and over again, every call is going to get added to the call stack, and eventually we're going to blow through that 2 megabytes, right? And that's going to cause the program to crash. Okay, so we're going to want to fix that. So let's go ahead and do that now. All right. So with a warning or a compiler error, we have some nice tools to help us with that. Okay. So the first thing we can do is we have our error list here, right? This should show up for you guys. If you do not have your error list, right, you want to go to your debug, where's it at here? View. You go to your view, right? You can have your error list, right? This unless you like accidentally closed it somehow, right? You should have your error list and your output list here, right? So with a compiler error or a warning, we can just double click and it will take us to where that error is at, right? So it's now we can see once I went there that it's actually talking about my copy constructor here has the recursive problem, right? And if we double click the other one, right, we'll see this error here, right, took us down to where we're using this uninitialized variable, all right? Sometimes, right, these errors can be a little bit cryptic, right? Like this, maybe we didn't really understand what that meant, all right? So what you can do is you can just click on the error and it should open up your internet browser, right? And it will bring you to the docs for that error or that warning, right? So it'll tell you, right? Hey, every path through a function contains a call to the function, Since there's no way to exit the function without first, the function will never exit, right? That's just what I said. Maybe that's a little bit more concise than what I said, right? It gives you an example, says like, hey, this code's gonna generate that error, right? We can see, right, that here's this function called func. It calls func in that control path. It calls func in that path, right? So if I go into the if, I hit and I call func again. If I get into the else, I hit it, I call func again, right? So I have no way of ever getting back to main because it's just going to keep calling the function over and over and over and over and over, right? So you can always just hit F1 to see some documentation about that error or that warning. All right. You can also, right, if it's like a crash or something like that, maybe, well, we'll just save that until we get to a crash. So I'm not seeing anything recursive here, right? Like I'm not calling the copy constructor within this, right? I'm using this shortcut, which we'll go ahead and let's go ahead and talk about that, even though maybe this isn't like the code might not be 100% correct, but we can still talk about what this is doing, right? So as I mentioned earlier when we were talking about the rule of three over on the whiteboard, the copy constructor and the assignment operator are pretty much doing the same thing, right? There's just a slightly different context of when those are called, right? One is called via an initialization and the other is called via an assignment, but more or less they give the same end results. So that means that more or less the code inside of them is pretty much identical, right? There may be a couple of small changes, but the majority, right, all of the deep copies and even the shallow copies, if there's something non-dynamic, those are all going to be the same between these two functions. So rather than write all of that code twice, right, we can use a little shortcut inside of our copy constructor. So this, right, well, what does this represent, right? What is this? All right, so this is the pointer to the invoking object. Well, what's an invoking object? All right, so let's come back over to main real quick. So let's, we'll just take this line here for example, okay? So set grades is a method of the student class, right? And that's why I'm able to call it from a student object, right? So when I'm inside of set grades, if I say like this arrow name, right? Because that's one of my data members, this is the address of student one, because student one is the object that is invoking or calling the set grades method, right? So when I'm inside of this call here to set grades, this is pointing to student one. When I call set grades on this line, this is student 2. All right. So this is the pointer or the address of whoever is calling the function. All right. So in the copy constructor, which is being called inside of this swap, temp is this, right? Because temp is calling the copy constructor, right? More or less, we could also write this like that. That's acceptable syntax as well, not as common. But here we can see, right, that temp is calling the constructor, right, and passing in another student, right? So coming back over here, right, if I take this, which is, again, this is a pointer, right? It's a memory address, and we use the asterisk, that dereferences that pointer, right? And when we dereference a pointer, that means I get to the value, right? I get to what I'm pointing to. So now star this, right, or the dereference of this is no longer a student pointer. It's just a student, right? So if I have a student and I assign it to another student, that is calling the assignment operator, right? So that is going to end up calling this function, all right? And so now, like I said, the majority of the code in these two functions is, if I was to write them out myself, would be like 95% the same. So this shortcut will just like save us some time in writing that code out twice, right? We don't, as programmers, we don't like to write the same thing over and over and over again if we don't have to, right? So we typically, right, we want to write extra functions. If we're doing something over and over and over, we might wrap that up in a function, right? This is kind of a way to kind of do that and cut down on some of that duplicate code, all right? So the problem with this, right, so we can, I mean, that's not recursive, right? Because we just said, well, this is the copy constructor, and if it's calling the assignment operator, those are not the same function, right? So why is it telling me that we're recursive? Well, Sneaky Justin here, right, made a problem here, okay? So what did when we were over on the whiteboard, right, what did I say the copy constructor and the assignment operator should take in as parameters? Do we remember? So yes, Zach, more or less, right? We should take in a constant reference to whatever class we're dealing with, right? So here, I'm not passing in a reference, am I? I'm just passing in an object. So that means that in order, when I pass in this object, it is calling the copy constructor to create that object. So basically, what's happening is when I call this copy constructor here, right, it's calling the assignment operator and making a copy of this object into here. And in order to do that, it has to call the copy constructor. So here, right, basically this is not a single function that has recursion, right? But it's what we call like an A-B recursion, right? Function A is calling function B, and function B is calling function A, right? We have no way to get out of that loop, right? So if we put a reference on this, right, then we're gonna fix that recursion, right? Now, if I try to build this again, right, so Control-Shift-B is gonna build, right? We're gonna get a whole slew of errors, right? And it brings us right back to here, right? And it says, hey, this operator equals overloaded member function not found in student, see declaration of student. So if we go over to student.h, right, we can see again over here, right, I don't have the reference symbol there, so I want to add that reference symbol back in, right, and build again, right? So we can see, right, that like just that one thing, right, took me from 1 error, 1 warning to 11 errors, 0 warnings, right? So we build again, right? And just that one little ampersand, right, cleaned up 10 errors, right? And so you want to tackle your errors just like from the first one down, because, you know, sometimes, you know, fixing one thing will kind of cascade and fix a whole bunch of stuff. All right. So let's go fix this next error here, right? It says that we have an uninitialized local variable called average, right? So here, right, an uninitialized variable, right, means that I didn't initialize it, right? That it has a garbage value, right? So I can't build and look at this, right? But C++ does not zero out all of our values by default, like super friendly C# does, right? If you want to do anything in C++, you have to tell it you want to do it, right? The reason for that is because it wants to be a fast language. In order to be fast, it only does what you tell it to do. All right. So if we initialize that variable, right, that's what it was asking for. It says, hey, you're trying to add to an uninitialized variable, right? So this average, before I set it to 0, was just some random number, right? It was like 8,572,641, right? And so we wouldn't be getting a valid total here if we were starting at some crazy number, right? So we need to initialize that guy to 0, right? So that we can actually get an accurate total there. Okay. All right, so we will build again. All right, and we compiled. Now we still have an error here, and I would like to talk about the 3 stages that we need to go through to get a working program or a running program, right? I can guarantee you that once we get this program running, it's not going to work, right? We have some other errors, right? So we've cleaned up some warnings, and we've cleaned up the compiler errors, all right? So there are 3 stages to running an application, or 3 stages to a build, I guess I should say, right? Build stages, all right? 1 is the preprocessor, right? That's going to be anything with the pound, right? Pound include, pound define, pound if, pound pragma, etc., right? Anything with the pound is going to happen first. So for instance, when we start our application, right, it's going to start, running through our code. So if it's going to hit this line first, it's a pound include. What does pound include do? All right. So yeah, it allows us to access that file, and more specifically, what it does is it copy and pastes the contents of this file right here. Okay. So we can't see this, right? But before we get to the next stage, right, which is compile, right? It opens this file. Right, so let's go ahead and open this file, and it copies the contents of this file into our file right here, right? So it's going to copy in all of this information, but this has some other includes, right? So when it opens this, when it sees this line, it's going to copy in all of this, right? And that has some includes, right? Hold on just one moment. So it's going to copy that, right? So if we open up this file, right? Oh, that's got includes, right? So it's just like this huge rabbit hole of code that is basically thrown into our file on this line, right? And then after it unrolls and does all of that stuff, right, then it's going to basically do the same thing for my little tiny student.h file that we have, right? So that's all done in this pre-processor stage. And then we go to the compile stage, right? And so that's where it's going to look and see, is our code all syntactically correct, right? So that's just like, is it work within the confines of the language? It may not do exactly what we want it to do, right? We may have problems within the code, right? But it's all legal code, right? So if we pass that part, then we get to the final part before we can build. And that's called the linker. And that's the error that we have right now. Okay, so we can see that we have a linker error. And unfortunately, when you double click on a linker error, it doesn't take you anywhere. So unlike a compiler error or a warning where, right, we double clicked it, it took me to the student copy constructor. When I double clicked my uninitialized variable, it took me to where that average was that I never initialized to 0, right? So this isn't doing anything, right? I'm clicking away at this, nothing happens, right? We can click on this linker error, right? And it'll tell us what the problem is, right? So it says the compiled code for a function makes a call to symbol, but the linker can't find a symbol definition. That really, that's not like the most layman's terms there, right? But when we come down to possible causes, right, it kind of gives us some possible causes, right? This is the most common that we're gonna see, right? If you ever have a linker error, it's probably this one or maybe this one. All right, so it says a function or variable is declared but never defined. Okay, so if we read this error here, it says a bunch of stuff, right? Unresolved external symbol, void, cdecal, display student, some parameter. It gives us some nonsense here, referenced in main. Okay, so typically what you want to do if you have a linker error is you just want to kind of read through it and see if anything looks familiar, right? So it's saying, hey, there's this display student function. Okay, so here's the function. Here's the prototype for that function, right? So a prototype basically says, hey, here's this function that exists, and here's how you can call it, right? Here's what it takes in, right? Here's the function name. Here's the parameter list. Here's a return type, right? But it's not the actual definition of the function, right? So where is the definition of the function? Well, there isn't one, right? So that's the problem, is I've told my program that there's a function called display student that takes in a student reference. And so I'm calling that function, but when it gets to this line of code, it can't link this line of code to the function definition because the function definition doesn't exist. So we can fix this error, right, by actually writing this function. So we're going to throw that down underneath main, right, and it basically tells me what to do, right? Display a student using its display method. So student dot display, and go ahead and build again. We've gotten past the linker stage. We have a building application, right? There's no errors. There's no warnings. We are building. Okay, so let's go ahead and run. So I'm going to hit F5 now, and I'm finally able to run the application, and boom, we crashed. It looks like we crashed pretty early because I can kind of discern that I didn't get to my displays, right? So somewhere before the display, right? Because this is the first time I like see out anything. So that means that somewhere in this code, there's a crash. Okay. So this may or may not be helpful to us, right? If we can't really ascertain. If we hit retry, okay, it took us here, right? So it's, that's what Zach mentioned, is pressing retry. There's a couple of ways that we could get to this error, right? And let's take a look at those. But yeah, one way that may work is if you hit retry, right? It might pop you over to where the problem is occurring, right? It's obviously it's not necessarily occurring right here on this curly brace, but it is somewhere in this function, right? We can run it again, right? We maybe we could like try to Google right? Google is a nice tool. So I can't copy and paste from here, right? But if we open up Google, where are we at here? This error here, right? We could say something like expression colon L buffer is too small, right? So Googling things, right? Google is your friend, right? It's going to help you track down a bunch of stuff, right? Make sure, right, you put things in quotes when you're searching for something specific, because otherwise it won't search for that exact terminology, right? Or that exact grouping of words. So quotes will allow you to do that. I had a student last month that didn't know you could do quotes in Google. So was like, oh, I guess I should maybe mention that, right? So here, right, we can see this guy on Stack Overflow, like I said, your favorite website, right, is getting that error, right? So some people answered his questions, right? So, all right. Another way that we could kind of track down where the crash is occurring is by setting a breakpoint. So we could say, hey, let's set a breakpoint here on line 45, because that's like kind of the first line of code, right? This is like some memory leak detection stuff that we'll go over when we get to our memory leaks, right? So if we hit F5, right? Well, first off, we'll talk about how to set a breakpoint. You can just click in this little margin over here, right? And that's going to set a breakpoint, this little red bubble here, right? You can also use F9 when you're on that line if you're a big fan of keyboard shortcuts. And then you can just run your application. So just you can either click up here, or you can hit F5, and that's going to run the application. And it's going to run up to, but not including, your breakpoint line, right? So it's going to tell you, right, that this is the next line of code to execute, is this line here. This is a function call, so I want to go inside that function. So again, you can use your things up here, or you can use the keyboard shortcuts, right? So step into is F11, right? So we can step into the function. And then you can use F10 to go line by line through the function until you experience your crash, right? And then that lets you know that, okay, so this like basically this is the line of code that I crashed on. All right, a stir copy. So what's the problem here, right? Or it's actually could be anywhere in this function, right? So does anyone notice a problem? I'm actually going to take this int off because I think I can get a warning. I can get a warning. All right. So before, well, actually, we'll tackle the error, and then we'll talk about this warning. So, so again, in these 3 lines of code, there's a problem. Does anyone see what the problem is? All right. So we'll just run through this. So we know what strlen does, right? Strlen is going to get the length of a string, right? You are correct, Matthew, but we're going to go ahead and walk through this so that kind of fully explain what's going on. So Sterling gets the length of a name or of a string, right? And the way that it does that is it passes in a char pointer, right? And it reads up until it hits the null terminator, and then it gives you the count, right? How many characters did I read until I hit a null terminator? Okay, well, this is something we call pointer arithmetic. So if I have my name being Frodo, if I add 1 to that pointer, then I get Rodo, right? Because basically I'm starting at the first element, right? Not at the sub-zero element. So I'm only allocating 4 bytes of memory when I really need to be allocating 6 bytes of memory, right? Because Frodo is 5 bytes, but then I have to allocate an additional byte for the null terminator, right? So I put this +1 on the inside of the Sterling, which moved my pointer over, rather than getting the string length of the full name and then adding 1 to account for the null terminator. Okay, so let's go ahead and build that again. I think we might make it a little bit further here, right? So we did get a little bit further, right? Because we actually printed out a name. So that means that we did copy that name correctly. Okay. Now, I want to, before we continue on and fix these other errors, I want to talk about warnings real quick. And I was able to get one that will disappear for us, which is good because I wanted to talk about this. So here we see a warning, right? This is a very common conversion warning. So Sterling returns size _t, and I'm assigning that to an integer. So it's telling me that there's a possible loss of data there. It's probably in this circumstance wouldn't hurt anything, right? A warning basically is a warning, right? It's saying, hey, there's a potential for something bad to happen, but it might not, right? It's not an error, right? But if, so I've compiled, I've built, right? And I've got this warning. Now I'm going to build again. All right. So I'm going to build and didn't show me my warning. I didn't do anything. I did not fix that warning. That warning is still there, but it's not showing it to me anymore. And so let's talk about why. So let me open up our project folder here, which is over here. Okay, so here is our project, right? There's our debugging. Here's our 3 files that we're working out of. And we're in debug mode. So here is my debug files. Okay, so whenever we build, we're gonna get these object files. For every CPP that we have, we're gonna get an object file. Okay, and this is some intermediary code before the executable actually gets created. All right, so when I build, so let's bring this over like this. So if I build again, nothing happens. All right, the reason nothing happens is because all of my code is up to date. right? I didn't make any changes between this build and the last build, so it doesn't need to change these files. They're still the exact same files, right? So it's only going to build files that have changed since the previous build, right? Imagine, we're working on like Red Dead Redemption 2 or Fortnite or whatever other awesome hot game is out right now, right? If I had to build every single file, that could take a while, right? Because that's going to have to compile hundreds or thousands of CPPs. And that could take a while, right? So we only want to compile things that are out of date, all right? Now, a warning is only going to show up on a fresh build. So now for our small applications, right, if we don't clean up our warnings immediately as we're going, and we want to kind of do a final pass before we say turn in our lab or whatever, then we can do a clean. So let's go ahead and clean our solution or clean your project. Either one will work. So let's clean, and let's watch over here what happens to some of these files. Nothing happens? Am I not in the right folder here? Debugging. Are we in? Let's see here. Let's build here. Okay, I was in the wrong folder there. I apologize for that. So here we are, right? There's our object files. When I clean, those files go away, right? So when you do a clean, it deletes all of that intermediary code that kind of Visual Studio uses to create your executable, right? And then when you build again, right? So Control-Shift-B, right? Now it created my files, which means it had to actually build them, right? And my warning popped up again, right? So make sure that you're either tackling your warnings as you go, right? So when you see a warning, you just take care of it, or before that final pass, right? Before you say, hey, I'm ready to turn in my lab or I'm ready to turn in my project, you go ahead and go up to build and do a clean and build, or you can just hit rebuild because it just does those two steps, right? So rebuild does a clean and build, right? So, right. So if we say clean and then we say rebuild, right, that would clean it again and then build all of our files, right? Okay, so let's go ahead and clean this up while we're here, right? Basically it says that Sterling returns a size T and I'm using an int, so we can just typecast the Sterling return to an integer, right? And that's going to clean that up. All right. Okay, so let's go ahead and move on. All right, so we build, right? We run again. Now we've crashed, right? This crash here, right, says that we're dividing by 0. Right, so if we look at num grades here, that's 0. So somewhere along the line, we didn't set num grades correctly. So we kind of need to figure out where we're dealing with grades at, right? So if we let's kind of walk through our class here. So all right, so our set grades is where we're kind of setting the grades at, right? We're taking in the number of elements here, and we're using that to loop through and copy the values from one array into another, right? But we're not setting the appropriate value there, right? So let's go ahead and set, actually we'll do it underneath, set my num grades, right? The member num grades equal to the one that's been passed in, right? So now I build again and we run. All right, so we're no longer crashing, right? So we've cleaned up all of the crash errors, right? But we still have some logic errors, right? One, our values are not correct, right? We're saying if I summed these up and divided them by 5, I should get 88. And if I summed all these up and divided by 10, then I should get 54.5, right? So, and then it looks like we're not actually swapping the names either. Well, we're not swapping anything, right? Like, this is just says Frodo Marty, all the numbers are the same, right? But we have a swap in there. So it should have flipped those. So the second it should have said Marty, then Frodo. And it's not doing that, right? So this is an instance where we don't have a crash, right? But our output, our program is not working the way that it's supposed to. Okay, so so now we're just going to have to try and figure out like what's going on, right? So let's tackle this one first, right? So we know that the grades are not outputting correctly. So let's take a look at everywhere that we're dealing with the grades. All right. So so here, right? So I'm copying everything over from the array that's being passed in, right? So these values, right? I'm copying them over into my data member, right? But as I mentioned like earlier when we were going through this, right, we want to cap these grades to this range. And we know that we've got some incorrect grades in there, right? So we probably want to go ahead and put some additional logic into this if, right? You can say something like, hey, if grade sub I is less than 0, then set final grade sub I equal to 0, right? So that's going to take any negative value and push it up to 0, right? And then we can do the same thing on the other bound, right? If it's greater than 100, then we set it to 100, right? Else final grade sub I, right? Not the whole array. And that should cap those grades. So let's see how that worked out. Okay, so I got the 88, right, which is what we should have for Frodo, right? But we're getting 54 instead of 54.5 for Marty here. So let's go ahead and continue on. It looks like when I'm getting my average, right, these values are integers, right? So I'm summing them all up, and then I am doing an integer by integer division, which results in an integer, right? So I need a floating point value. So there's a couple ways that I could do that. One, I could just convert this average to a float, right? So now I have a float divided by an int. This division here, this calculation is going to result in a float because it's considered the superior type to an int, right? It has a higher precision, right? We could also just do a typecast, right? I could say like, hey, typecast this to a float, right? So it's an int all through here, but then I'm just saying, hey, in this one little instance here, treat that as a float. All right, so now we should get back to 54.5. That's what we wanted. Okay, so now we've got all of the float, or I'm sorry, the grade stuff looks to be correct now. How's everyone doing? Okay, so now let's take a look and see what the heck is going on with these things not swapping, right? So we're gonna have to, we know it's in either the copy constructor or the assignment operator, right? Now I used the shortcut, right? So that kind of eliminates and says like, hey, it can only be in this function here, right? So let's see. So I'm doing this right here, right? This is called a self-assignment check. Right, this is making sure that I'm not trying to assign an object to itself. If I do that, then it's going to cause some problems when we're dealing with deep copies. So every assignment operator needs to have this check in here, right? It's checking to see if this, which is the address of the invoking object, right? So that's a memory address. If that's the same address as the address of the one being passed in, then that means that they're the same object. Oh, so that means that I should probably use not equals, right? Because if they're not equals, then I want to copy. Right? If they are equal, I wouldn't want to do this. So let's see if that fixed it, right? Sometimes you make one small change and then you build, right? I recommend like compile every few lines, right? So you can clean up your compiler errors as you go. And then, you know, once you finish a function or whatever and you want to run the test, then, you know, go ahead and build and try it out, right? You'll see how cool the unit tests are once you get over into to lab 2 and moving forward. All right. All right. So making some good progress, right? We've got the names seem to be swapping now, right? Frodo, Marty, Frodo. Okay, so that's good. That's progress. And then like something went haywire with the averages there, right? And then we also, if we're observant, right, we'll see that we have some memory leaks now. So I'd like to fix the stuff with the grades first and see if we can fix that. And maybe, I don't think it'll clean up these memory leaks, but I'd rather save the memory leaks till last. All right. So let's go ahead and see if we can figure this out. Okay. So again, this is a logic problem, right? There's something that I've done that is causing me to get the wrong result, but it's It's not a crash, right? So this is something where you really have to kind of debug, right? Maybe go line by line and see what the problem is, right? So let's go ahead and do that. Let's go ahead and set a breakpoint here, right? So this is going to get triggered when I enter into my swap function over in main. And we know that the name stuff seems to be swapping okay. So I'm fairly confident that this code is correct, right? Because it is swapping those names. So I'm going to go ahead and do this here. All right. So over in main, right, we can take a look at who was being passed into the function. All right, so Frodo was being passed into the function, right? We can see that here. Frodo was being passed in, so that means that Marty was the original object, right? Now the name has already been changed to Frodo, so they're both named Frodo, right? But this was Marty, right? And so now we're trying to copy over Marty's grades with Frodo's grades, right? So our num grades right now is 0. So that means that this loop isn't even going to run, right? If I hit F10, we just skip the loop because num grades was 0. All right. So that's obviously a problem. Before we went into this loop, we're using our data member, but we didn't set that data member to the same value as the one being passed in, right? We might not have the same number of grades, right? So this is, we're deep copy the name, right? And we can shallow copy the number of grades. So num grades equals assign dot num grades, right? You can do that, it really doesn't matter. And we'll build that again. Let's close up the old version and we'll run that. All right, cool. So we're making progress, right? The sort works, the values are correct, right? So the swap seems to be working. The last thing that we're going to need to clean up here is our memory leaks. All right. So luckily, we have some really cool memory leak detection code that we can use that's really good for these linear types of applications, right? The applications that we're working with in the program up to this point, and probably throughout this month anyways, and I think you're going to get into some real-time programming applications, or more real-time programming applications in C++. Next month, I think you do some stuff in software engineering that's real-time. So this memory leak detection stuff might not work as well in a real-time application, but we're not in a real-time application, so this will be fine. So we've got this code up here, right? This is going to be available to you in all of your projects. It's turning on memory leak detection code. Don't worry about this line. You never have to memorize it. You don't really need to know what it does other than it turns on memory leak detection. If you asked me, like, in the middle of the street, what this line of code was, like, hey, what's the line of code to turn on memory leak detection in C++, I would not have a clue. I would maybe know this because I've been looking at this memory leak detection stuff for years, but I couldn't tell you what this is, right? So I would not be any good, right? So you don't need to know this, just copy it. If you ever need to use it in your own project or whatever, just copy and paste it from some old project. right? It's fine. Or you might have some other memory leak detection stuff in a real-time application that may work better for you. We'll talk about why in just a moment here. Okay, so what we're gonna do, right? This turns on the memory leak detection. So that is what's enabling us to see this, that we have memory leaks, okay? Now we can see we have 2 memory leaks, and they are at these allocation numbers, 162 and 163, all right? So what happens is every single variable that gets allocated within an application, whether it's dynamic or not, or well, no, I take that back. Only dynamic allocations. There's a bunch of allocations that can happen kind of behind the scenes as well, right? So every allocation is going to be assigned a number. All right. So this string that I created at this address, that's 12 bytes, and stores this data, right? We can, since it's a string, it'll tell us the string there, but normally if it's an int or some other non-string thing, you won't see anything inside these angle brackets, or maybe you'll see just like a couple characters that are just like the ASCII representation of your data, right? So it's telling me that leaked. Okay, so I don't know where it leaked from, potentially, right? So what you're gonna do is you're gonna take that 163 and you're gonna put it in here. All right, what this line of code does is it says, hey, when you hit allocation 163, set a breakpoint or trigger a breakpoint. So now when I run the application, boom, it took me to the line of code where I called new. All right. Now, sometimes it won't do this. All right. Sometimes it's going to take you into the actual function new. All right. In that case, what you want to do is come over to your call stack, and you'll be up here and it'll say like new. You want to kind of walk down the call stack until you get to code that you have written. And then you double click that and it'll take you to this line, right? Like if I hit main here, right, it took me to the previous call in the call stack, right? So the call that's calling new and allocating the string Marty McFly is here in main, right? And so this is where my crash is occurring. Okay, so let's take a look and see if we can track down this memory leak. And I think if we clean up this one memory leak, then we'll clean them both up, right? So the reason why this is okay with a linear application is because every time I run this program, or pretty much most of the programs that you guys have written so far, they just run through to completion, right? There's no real like branching paths or any real timeness to it, right? Like there's not like if we were playing like a first person shooter, right? And we hit the trigger to fire a bullet, or left mouse click if you're a PC gamer, and that dynamically allocates a bullet, right? So that might not allocate at the same time every time we run the application, right? So therefore it's not going to have the same allocation number every time, right? And so that's why this doesn't work very well for real-time applications, because we're specifically telling it, set a breakpoint when you hit this allocation, right? And that's not going to be the same every time in a real-time application, right? For a linear application, right? Even something that's like menu-based, right? Like I don't know if you've had like applications where you had like a switch or something like that. You were creating different class objects. You could recreate, you could rerun the program with the same inputs, right? And then the allocation number would be the same. Okay, so this is where the allocation happened. Okay, so we know it's name that's leaking. So let's see where I need to delete that. All right, well, I'm cleaning it up in the destructor. That's good, right? I want to, when my object goes out of scope, I need to delete the name. Okay, so here I'm calling new again, right? So what's happening is I called new, right? So let's kind of walk through the steps here. I called new here on this line, and I called new on this line as well, but let's just take one of them for an example. So I called new, right? And then when I came down and I did this swap, it came in here and it called new again, right? But I didn't delete before I called new again. So that means that that original memory, that original name went away, right? It's still out there in my heap, right? It's still sitting there in my RAM, but I didn't clean it up. I didn't tell it that it's okay to reuse that memory. So before we call new again, we need to delete the name, right? So we delete, we free up the memory. We say, hey, Marty McFly, that's fine, go away. And then we reallocate and say, hey, let's get us a new address and copy in Frodo Baggins into that, right? So now let's go ahead and run it again, see if we cleaned up our memory leaks. All right, I don't know because the program didn't exit. We hit our breakpoint again. We hit our breakpoint because that's what this line of code says to do, right? It doesn't say, hey, if 163 is leaking, then set a breakpoint. It just says, hey, when you hit 163, throw up a breakpoint, right? So after you think you've cleaned up your memory leaks, you need to either comment the line out, or I set it back to -1 because allocations start at 0. So I'm never really going to hit -1, right? I have to like have, billions of allocations before I get around to -1, which is, I mean, you got bigger problems in that case, right? So let's run our application. We're getting the right output. Everything's swapping correctly. And we can see that we no longer have any memory leaks. All right. So any questions on this? So these are the kind of the types of things that we went over today, right? We went over warnings, right? We cleaned up a couple of compiler errors, right? We cleaned up a linker error. We had a number of logic errors, right? With the grades specifically in this case, right? And then and not allocating the right amount of memory for our strings. That was another logic error, right? And then we had a couple of memory leaks that we cleaned up as well, right? So these are all things that you will encounter as programmers, right, on pretty much a daily basis, right? You might not see all of them every day, right? But I guarantee like you'll see them all pretty frequently, right? And you'll probably see all of them tonight on the debugging lab. I think all of these guys will make an appearance. So I think we did a pretty thorough job here. Like I said, the lab tonight mimics this fairly closely. It's not exact, so there will be a couple of different errors, but you should have the tools to be able to track those down, right? You should know how to set a breakpoint. You should know how to, double click in your error list to get to the right place. You should know what a linker error is now. You should know how to Google an error, right? If it pops up, and try to get some information that way. You should know how to walk through your code, right, after you've set a breakpoint. And we talked about how to track down your memory leaks, so you can do that as well. All right. So if there aren't any other questions, I think we're going to wrap things up. Like I said, there will be lab tonight at 5. Phil will be available to answer any of your questions pertaining to the tools, right? So for this one lab, right, we won't be able to help you solve a particular error, right? You're saying, hey, I'm getting this error in my debugging lab. Can you tell me how to fix it? Unfortunately, we're not going to be able to do that, but we can say like, okay, well, here's how you would track down a memory leak, right? Or here's how you can figure out how to fix this compiler error or this linker error, right? So we'll help you with the tools, right? But we can't help you with like the specifics of the lab itself, right? This lab's not weighted as high as the other labs, but it's there to hopefully get you more comfortable with debugging, right? So that you can be sufficient, right, in fixing your errors. We're not trying to limit our help with you, or it's not that we don't want to help you, right? But we want to make sure that you're self-sufficient in the future when you don't have us around to walk you through things, right? So yeah, I think that about sums it up. So if you have any other questions or any errors that we want to try to recreate or anything like that, we got some time, right? We can roll till like 4:15 if you want to, but if not, then we'll go ahead and wrap things up until Wednesday. Okay, well, I think we're gonna wrap it up then. I highly encourage all of you to show up to every lecture, right? Like being live, asking questions, interacting will be beneficial to you, more beneficial than just watching it after the fact, right? Because if you have a question, right, we can't address that live. So, and other students may have that question as well, right? So like if you ask me a question on Discord and we talk over DM, then you're getting the benefits of that help, right? But then some other student might have had that same question and they didn't ask, right? So I want everyone to show up to all of the lectures. Yes, Deshaun, they're all at 1 p.m. on Monday, Wednesday, Friday. except for the couple days for the midterm and the final. So if you look at the dates on FSO for the Zoom archive, all those dates should be correct. And that's where the links to these lectures will be. So I'll upload them to YouTube, and I'll put the link on Discord, and then I'll also update that activity with the link as well if you want to go back and watch this again. So, all right. So again, highly thank the few of you that did show up today. I really appreciate you guys showing up. But we should see a lot more moving forward, right? I've got how many people are on campus? Right. We've got, I think there's 15 campus students, right? You guys should all be here, right? Unless you have a valid excuse, right? You would be in class if you were on campus, right? So why aren't you here? I'm not trying to be a jerk, right? But I'm trying to help you learn, and I want to interact with you. So please, please, please show up to these live lectures, right? And also to the labs, right? Take the opportunity, treat it like a campus class, and you'll have a more rewarding experience. So, all right. So I'll get off my soapbox now, and I will see you guys on Wednesday. Take care.